All right, we're gonna do part two. We're gonna do solving systems of linear inequalities from word problems. Okay, so let's go find a word problem down here that we can do. All right, number 5. It says, now that you've finished high school, you want to move out and live away from home. You need to make at least $540 per week to cover your expenses. Okay. You're currently working 2 jobs. Let's see, you make $18 an hour cleaning at the auto body shop and $9 per hour clearing tables and washing dishes at the restaurant. You don't want to work more than 50 hours per week. Define your variables, write the equations, and graph the solution. All right, the first job you're making $18 at the auto body shop, and the second job you're making $9 per hour at the restaurants. And of course, you don't want to work more than 50 hours per week. Okay. So let's go ahead and define our variables. All right, for x, x is going to be, let's call this at the auto body shop. Let's call x the hours we work at the auto body shop. And we'll call y the hours we work at the restaurants. So those are my variables. Let's go ahead and write out 2 equations. Okay. The first equation is to make at least $540 per week, we need to be working so many hours at the auto body shop, making $18 an hour, and also so many hours per week, making $9 per hour at the restaurants. So if I'm making $18 an hour at the auto body shop, which is X, and making $9 an hour at the restaurants, the combination of those 2 jobs has to be at least $540 per week. So this combination has to be greater than or equal to 540 per week. So it has to be greater than or equal to 540 per week. 540. Okay. So this is my first equation. The second equation is a combination of these 2 jobs combined working no more than 50 hours per week. So if X is the hours of the auto body shop and Y is the hours of the restaurant, this has to be less than or equal to 50 hours. This has to be less than or equal to 50 hours. 50 hours, there you go. All right, those are my two equations. Okay, so we've defined our variables. Okay, we've written our equations, and now we just need to graph the solutions over here. Okay, so looking at the graph on the right hand side, there's no ways I can put 1, 2, 3, 4. That wouldn't work because these numbers are too big for that. So if we can do a scale of 10, make this 10, 20, 30, 40, let's see, 60, that should work. Okay, we'll do a scale of 10. I'm going to graph the second equation first. The x plus y is less than or equal to 50. I'm going to do that one first because that just looks a lot easier. Okay. The way I'm going to approach this equation is by finding my x-intercept, my y-intercept, and then combining those 2 lines together. Okay, I'm going to connect those 2 lines together. To find the y-intercept, I just need to plug in 0 for x. So I need to put in 0 for x. Okay, this is my same green equation. So this would cancel out. So y is going to be less than or equal to 50. So my y-intercept is right here at 50. To find the x-intercept, just plug in 0 for y. So the same deal, I'm going to put in x plus 0, my y value, less than or equal to 50. Of course, this goes away. So x is less than or equal to 50. So my x-intercept is going to be at 50 as well. This is where 50 is. Again, if we look at our scale, 20, 40, 60 there. All right. Now I just need to connect those 2 dots together. Okay. And this is going to be a solid line It's a solid line because it is less than or equal to, okay? So that's somewhat of a straight line right there. Now I need to find my x-intercept and y-intercept for my first equation, okay? So same concept. To find my y-intercept, I'm going to plug in 0 for x. If I plug in 0 for x, my equation is going to look like this. So it'll be 18 times 0 plus 9y is greater than or equal to 540. Okay? Anything times 0 will be 0, so this goes away. So 9y is greater than or equal to 540. Divide both sides by 9. Those cancel each other out. And so y will be greater than or equal to 16. Okay? So the y-intercept will be right here at 16. Let's do the same thing for the x-intercept. All right, for the x-intercept, I'm going to plug in 0 for y. 18x plus 9 times 0 greater than or equal to 540. All right, so 9 times 0 will be 0, so those cancel out. So now my equation will be 18x greater than or equal to 540. Divide both sides by 18. Those cancel out. So x will be greater than or equal to 30. Okay. All right, so plug in the x-intercept right here at 30. And then connect those two dots. So somewhat of a straight line, hopefully. This will be something like that. Okay. All right. So now we need to go ahead and shade one side of the line. Okay. For the green equation, since my equation says y is less than some number, if y is less, when you see the word less, it means it's going to be below the line. Okay. So anything below this line will be a possible solution. The reason being is because of this less than or equal sign. On the other hand, since this is saying greater than or equal to, it's going to be above the line. So if it's greater than or equal to, it'll be above the blue line. So anything above this blue line should be a possible solution. So we can see that they overlap in this area over here. So when I'm looking for a possible solution, I need to find a coordinate in that that scalene triangle over there. Okay. So let's pick a random coordinate. Okay. How about one right here in the middle? Okay. This one looks like it's going to be 50 and negative. Let's see, it's negative 10. This is negative 20. So this would be negative 20. So let's see if this is a possible solution. If I plug in 50 in for x over here, then I plug in negative 20 in for y, that will be greater than or equal to 540. Okay. But also plug in 50 in for this x over here and negative 20 in for this y over here. It will give me less than 50. Okay. Less than or equal to 50, which is the goal. At first sight, this is a possible solution. The problem with this one is that if you think about the word problem, it's saying we need to find a solution where he works so many hours at the auto body shop and so many hours at the restaurant. Now, can someone work 50 hours at an auto body shop? Probably. That would make somewhat sense. Maybe, 40, 50 hours. But can someone work negative 20 hours? Can someone work negative 20 hours at work? No, that's not a possible thing. That's not a thing that someone can do. Someone can't work negative 20 hours. Okay. So therefore, we can't have a solution below this x-axis, which means we cannot have a solution below this x-axis right here. this is a no-go for us. Okay, we can't work at negative hours. So therefore, this is not a correct solution. Okay. To find ourselves a correct solution, we need to have something in this triangle over here above the x-axis. Okay, so if we pick up this red coordinate here, that's 30 and 10. Perfect. Now that's feasible. That is a feasible solution. That's something we can do. That is a good solution. They're both positive. Um, and so that would be a correct solution. Also, if we chose something along the on one of the lines, let's say right over here, which is 2020, even though that's on the line, that's also a possible solution because it can be also equal to, right? It can also be equal to. So therefore, it is a possible solution. Right? Hopefully that helps.